All right, this is lesson 21, graphing linear inequalities in two variables, part 1. So we have the section 1. We have, here's the expression, we have 2x plus 3y. We're going to decide if the values in each ordered pair make the value of the expression less than, greater than, or equal to 12. So we're just going to plug these in. So just a reminder, when we have a coordinate pair, which it already tells you, it's x, y. So we're going to plug in 0 for x and 5 for y into our equation. So we're going to have 2 times 0 plus 3 times 5. So we're going to get, that's going to be a 0, and this is going to be 15. So 0 plus 15 is 15. So if I were to write down that 0, I can just get rid of it. And I know that 15 is greater than 12. We're going to do that again with 6, 0. So this one goes to there. So I'm going to put a blue arrow. We're going to go down here. And I know that line is not very straight. So we're going to do 2 times 6 plus 3 times 0. 2 times 6 is 12. 3 times 0 goes to 0. It is nothing. And 12 is equal to 12. Okay, next we are going to do, draw an arrow down here. We're going to do 2 times negative 1 plus 3 times negative 1. That's going to give us negative 2. And I'm going to put a plus negative 3, which if you can recognize that that is the same as minus 3, then go ahead and put minus 3. So we're going to have negative 5. That is definitely less than 12. I know I got an extra point in there. It'll be all right. And lastly, we are going to do negative 5 and 10. So we're going to have 2 times negative 5 plus 3 times 10. 2 times negative 5 is going to be negative 10. Plus 3 times 10 is going to be 30. Negative 10 plus 30 is 20. Again, a reminder for whenever you are adding numbers together. If you have a positive and a negative, you subtract the numbers and keep the sign of the bigger one. So 20 is going to be greater than 12. All right, let's go to the next page. We have 21.2, solutions and not solutions. Here are 4 inequalities. Study each inequality assigned to you and your group. We are not doing the groups. We're just going to work through them right now. We are going to find some coordinate pairs that represent the solutions to the inequality and some coordinate pairs that do not represent solutions. Plot both sets of points, either use 2 different colors or 2 different symbols like X's and zeros. It'd probably be better if you guys use different colors, but I don't think I have my colored pencils out in my classroom. If you guys have different colors, do that. Like if you have your own different pens or pencils. Otherwise, if I were there, I would be pulling those out for you guys today. Let's see here. So plot enough points until you start to see the region that contains the solutions and the region that contains a non-solution. So look for a pattern describing the region where the solutions are plotted. All right. So let's start with, let's just do x is greater than y. So it says to find some coordinates to do this. I would like to, let's see here. What I'm going to do, I'm going to do this a little bit differently than what it is saying to do. So we are going to say this is in slope-intercept form. Does everybody see that? Because if I add a 0, that's in slope-intercept form. So I am going to graph this equation. So I'm going to go to the 0 on the y-axis. And then I'm going to go up and to the right. So up 1 and to the right 1, because that's going to give me a positive slope. So my line needs to go through all of these points right here. And I know these are, some of them are a little bit off. I'm just trying to mark them real fast. So when I draw my line, I know if it's in the right spot. Okay, you guys see that? So I'm going to draw that real fast through there. Okay, I know that my line needs to be solid because this is an equal to sign. When we go down to do one of these ones, it's going to be a dotted line. So I may just leave it like I just did. Now we need to see, so when we have inequalities, all of the answers that could fulfill the inequality are either going to be above or below the line. In this case, it's going to be to the top left or to the bottom right. Okay? So if we plug in some points, let's say, here's where they're talking about picking some points. So if let's do 4, 2. And I'm going to do 4, 2 in blue. If we plug in 4, 2, for negative 2, we have negative 2 is greater than or equal to 4. That is false. So I know that one does not work. I'm going to plug in, I don't want to use the same point. I'm going to do, let's do 2, negative 2. So I'm going to put in a 2, greater than or equal to 2. That is true. So, true, false. The side that has a point that satisfies the inequality is true. The entire side is going to be a solution. If I were to pick any point on the bottom right side of this line, then I would get a true equation when I plug stuff in, when I plug in numbers, okay? Continue on this one outside of the video, going through and plugging in numbers and verify that that's true, okay? Because I think that's the whole point that they wanted you guys to do in a group, but we can't do that right now because of COVID. So I'm going to go ahead and go on to this next one. We're going to divide both sides by negative 2 to get y is less than or equal to 2. I changed my sign. If I have not addressed this yet, you flip the sign when dividing by a negative. I had somebody ask me yesterday if, like, when you're solving an equation, if we have like a big long inequality and we're solving one side of it and we have to divide to solve one side of it, if we flip the sign then. We do not flip the sign whenever we are just solving one side. We flip the sign when we divide on both sides by a negative. Okay? So y is going to be less than or equal to 2. So I'm going to go to 2 over here. Okay, so if I plug in, nope, not on the x-axis, on the y-axis, 2, my line is going to be a horizontal line through the y-axis because it is y is less than or equal to 2. So for this one, I can plug in just any value for y. So I'm going to plug in 4. It's 4. And actually, I'm going to plug it into the original equation. So we have negative 2 times 4 is greater than or equal to negative 4. We will get negative 8 is greater than or equal to negative 4, and that is false. So I'm going to plug in, let's say, negative 2. We'll do negative 2 times negative 2 is greater than or equal to negative 4. Negative 2 times negative 2 is positive 4. And that is greater than or equal to negative 4. And that is true. So we would shade everything down here because any value down here is going to make this inequality true. Okay? And I know that was kind of crazy looking. If I were doing this on paper, I would be doing this a little bit better. Actually, let me see if I can get, there we go, shading. I'm going to shade it and change my thickness to where it doesn't take me as much time to do this. There we go. Shade it like that. And I'll go back over here and shade this side a little bit and clean that up because I got it on the right side of the equation. There we go. Okay. All right, let's do this one. We have 3x is less than. Oh, and I forgot to address that I did a solid line for this inequality right here. So we have 3x is less than 0. So I'm going to divide by 3 on both sides to get my x by itself. And my sign stays the same direction because I didn't divide by a negative. I just divided. So x is greater than 0. So on the x-axis, I'm going to draw a line through 0, but this time it's going to be dotted. It's dotted because it does not include 0. So I'm going to pick a point on the left, and I'm going to pick a point on the right. And let's see here. So x needs to be less than 0. So over here I picked negative 4, 2 for the pink dot. So we use the negative 4. The 2 doesn't matter in this situation. So negative 4 less than 0. And I should actually plug that into the original equation. So let's do that. So 3 times negative 4 is less than 0. Negative 12 is less than 0. That is true. So now we're going to shade. And we're going to shade on the left side. We can double check the right side by plugging that in to the original equation. So we have 3, whoopsie, I need to change that. So 3 times 4. I somehow picked the same number. That's okay. So we have 12 is less than 0, and that is false. So we shade the side that is true. Okay. I want you guys to do this one on your own. I'm going to go ahead and go to the next page. Sketching solutions to inequalities. Here's a graph that represents the solutions to the equation. We have x minus y is equal to 5. So let's see here. Actually, because I did all of the last page like how I'm telling you guys to do how this is expecting you to do this, I want you guys to do this page as well. You can do it as a class today if you want to. So 21.3, I want you guys to do that in class. If you need to go back and look at how I did these ones, absolutely go back and do that. But I want you guys to see this, and I want you to be practicing this so that you understand how to do this when you get to your practice problems, okay? So I'm going to skip this page because I want you to do this, okay? And I want you to do on this first one, I want you to plug in a number and see which side needs to be shaded for this inequality right here, okay? So I'm going to go to the next page. yeah, I think you guys can do this as well. I think you can write an inequality whose solutions are represented by the shaded part of the graph. I will do, I will do A and D. So I think if I do A and D, then you will be able to find out B and C really fast. So I see that my line goes through the x-axis. So I'm going to have an x value. I see that it goes through 3. So over here. I see that it's shaded on the right side of 3, which is greater than 3. So x is going to be greater than 3. My line is dotted, so it is not greater than or equal to 3. So here is an equation, or inequality, an inequality, whose solutions are represented by the shaded part of the graph. There could be other options for this inequality. You could have something else. You could have all kinds of things, but that was just working through what I see right here. So let's look at D. I have, so I have a slope. I can see that automatically. I have a slope. I can see that my line goes through the y-axis at 0 right here. You guys see that? So that means my y-intercept, so if I had a B, is 0. If I go up from my slope, or from my y-intercept, and then go right to get to the line, I have a slope of 2 over 2, which is the same as 1. So my M is 1. Okay? So I can say y, let's see here. I'm not going to put a sign in there yet. Typically we would put equal to, so I'm going to leave it to where it's like a placeholder right there. And then I'm going to say x, y equals x. Okay? So because we have a plus 0, so I don't have to put the plus 0. So we have it shaded below the line. So is that where y is greater than or less than x? So if I go down here, let's look at this one, -2. Is -2 is it less than, greater than, or equal to 0? And it is less than. So our equation for this one is going to be y is less than or equal to x. Okay? All right. So I want you guys to do B and C. These are very similar to A and D. The difference that I can see automatically is that this one goes through the x-axis, this one goes through the y-axis. This one goes through the same point. You guys see that? This is the exact same line on C. What's the difference? Can you tell me? Go ahead and do that one, and I'm going to go to the next page. Let's go ahead and skip the are you ready for more? I may decide that we go back and do this like as a preparation for the test. But I'm going to stop this video right here, I believe, and I will get the next one uploaded.